Good evening. Good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening. What was the last thing we dealt with in the previous class, and what are we supposed to deal with?
Sir, virtual work.
Virtual.
work.
Did we apply virtual work to all the problems in the
Yes,
assignment?
sir.
Yes,
Yes,
sir.
sir. Except the fifth and seventh one.
Yes, sir. Three were remaining.
You had to tell us today that
So the
I
exception.
had to tell you.
the fifth and the
The
seventh.
So fourth, fifth, and seventh.
Fourth, fifth, and seventh.
Okay. Okay.
Yeah, fourth, fifth, and seventh.
No, it's not that you cannot apply to those. You can comfortably apply even for those. But the problem there is only one half of the problem is given to you there. Consider this first of all. First to solve this, you will have an idea. Take this as M1. Now this I have extended. Fourth problem, extended version of extended. I am actually drawing the fourth problem. I am pulling this with a velocity of 10 meters per second, and I am asking you for this velocity. I am pulling this with a velocity of 10 meters per second. I am asking you for this velocity. Observe the fourth problem first carefully and then look at the diagram. Fourth problem, the pulley was going up, right?
Yes, sir.
Yes, sir.
Right? Now, technically, if this is going to the left, the pulley is also going up with 10 meters per second.
Yes.
Basic problem did not change, but this is the complete problem. What is given to you is only one half of the problem. Now, why are you telling us this? Because principle of virtual work means when I tell you net work done by tension, it is on whole of the system. The system should be consistent on its own. Somebody is pulling this with 10 meters per second. The other half of the information is missing. Right? Somebody should be pulling it.
Yes. Yes, sir.
Now the work done by that person also is incorporated in this. You are taking here 2T. You are taking here T. Net work done by tension on this pulley is 0. Net work done by tension on this pulley is 0. Why? 2T in the upward direction, 2T in the downward direction. You cannot tell me that work is done on this pulley. It becomes 0. Now have a look at this. This is 2T.
Yes, sir.
2T and 10 meters per second are in opposite direction.
Yes, sir.
Minus 2T into 10
Yes, sir.
plus T into V is 0.
Yes.
Is the answer 20 meters per second?
Yes, sir.
So if I were to solve only fourth problem, I should have this additional information that the person who is pulling this with 10 meters per second. He is doing some work.
Yes, sir.
Now, this was incomplete problem. So when you apply principle of virtual work to one half of the problem, it doesn't work. So this person is pulling it. When this person is pulling it, have a look at it. On him, tension will be in downward direction.
Yes, sir.
10 meters per second, because this is going up, he should also be going up with 10 meters per second. So 2t is in the downward direction. Whoever is pulling it, 2t on them is in the downward direction. 2t into 10 obviously is with a negative sign. 10 is upwards, 2t is downwards. Plus t into v is 0. I get v as 20 meters per second. Directly, you could not apply to the fourth, fifth, and one more problem because they gave you only one half of this problem. And principle of virtual work says net total. What is the second word?
Oh, total.
Total work done by tension on whole of the system will be 0. So taking this person also into consideration is essential. I'll draw this person flat so that diagram looks clean. This person is pushing it. He is also moving up with 10 meters per second and 2t is in the downward direction for him. For the pulley, 2t is in the upward direction. So 2t and 10 meters per second are in opposite direction.
Yes.
Let me apply that to fifth problem as well and show it to you. Take it down till here. Tell me when I can rub the board.
Done, sir.
Sir, I have a doubt. Sir, I didn't understand how did we get that plus TV in that v is equal to 20 meter per second equation?
TV. P and V.
But,
Work done by
okay, sir.
P into technically X, dx by dt directly. You will technically I took x1, x2, differentiated x1 and road velocity. Here directly a road velocity.
Okay, sir.
Now, fifth problem. This man is pulling this in the upward direction with how much velocity? 10 meters per second. Upper end and lower end of the string should be moving by the same distance of 10 meters per second. If not, the string will slacken.
Yes, sir.
Yes, sir.
Right? Now, if this is 2t, this will be t, this will be t, this will be t. This is going down with 5 meters per second. You're taking this to be BA. Am I right?
Yes, sir. Yes.
Now, have a look at this. Net total work done by tension on the pulley will become 0. 2T into 10, 2T into 10. This 2T is in the downward direction, so I'll have negative 2T into 10. This 2T is in the upward direction, so I'll have positive 2T into 10. This will be 0. This will be 2T into 10 with a negative sign. On this man, 2T is downwards, 10 is upwards. Here, minus T into 5. They are in opposite direction. Plus T into VA should be 0. TTP. VA is equal to 25 meters per second. What is the answer given?
25.
225.
Whole of the game was in understanding that some work is being done by this 2T. Because principle of virtual work says net total work done by tension on whole of the system is 0. One part of the system I cannot equate it to 0. I will give you 2 minutes, solve the 7th one. I'm waiting for you people. You people tell me that you got it, then alone I'll proceed.
Sir,
Hmm.
sir, why are we means considering it to be pulled by a single block only? So means it can be a chain of blocks also.
Maybe. You have no problem.
Okay.
Put n number of blocks. 1 man over 1 man or 1 man, any number you put, it will turn out to be the same.
Okay.
So 7th done.
Okay, okay.
So done.
Now we go one more step ahead.
Yeah.
What if the string is not moving along its length? What if this string is not moving along its length? If you take this distance to be XA and this distance to be XB,
Yes.
now how do you apply constraint relations? This will be XA cos theta and this will be XA sin theta. Listen carefully. The resultant velocity which you have, that velocity need to be resolved along the length of the string and perpendicular to the length of the string. Mind every word of mine. Resultant velocity which is given, that will be resolved along the length of the string and perpendicular to the length of the string. Along the length of the string and perpendicular to the length of the string. What is along the length of the string will contribute to elongation. Perpendicular to the length of the string will not contribute to elongation.
Yes.
Fair enough?
Yes, sir.
Yes, sir.
Yes, sir.
From the center, this end is moving away. I'll call it XA cos theta. This end is moving towards XB 0. XB is equal to XA cos theta. VB is equal to VA cos theta.
Sir, means in this, sir, XA sin theta will not be used.
XA sin theta's component in this direction will be 0.
Okay, yes. Sir.
Why do we resolve a vector at the first place? Purpose is that the perpendicular component doesn't interfere with this component. If this is y component doesn't interfere with my x component.
Yes.
Hence we resolve a vector. Right?
Yes, sir.
थोड़ा ध्यान से सुनिए. You people will get this doubt after some days. I'm clearing the doubt in advance, which is my mistake. I know that. I should clear the doubt only when you people get. But then, till then, I don't want to keep it pending. I know I'm committing a mistake, but yet I will. Every year, half the way through, 6 महीने के बाद, 7 महीने के बाद, at least one student will come and ask me, "Hey, XP है ना sir? So this end also should move by the same distance XB for the length of the string to be equal."
Yes, sir.
Yes.
Yes, sir.
What that student does is, he will resolve XB along this direction, XB cos theta, and I will equate it to X. His answer is XB is equal to XA by cos theta.
Sir, but is that logic wrong?
Yes.
Logic तो सही
The
लग रहा है.
motion is
Sir, गलत है
correctly,
sir.
no?
Sir, because
It's
The
wrong.
angle made is wrong.
Sir, perpendicular नहीं आ रहा है ना दूसरा component.
Resultant velocity is this. Resultant velocity is this. This must be resolved along this direction. XB को अगर इस direction में resolve किया, what is the other component? This is
XB
XB
sin
sin
theta.
theta.
Yes.
Yes,
sir.
sir.
Yes.
You mean to say XB sin theta will not contribute to the elongation of the string?
It will, sir.
It will.
Not perpendicular. Purpose of resolving is lost.
Yeah.
Purpose of resolving is lost. I will take one more example to explain, which you will be 100% convinced. I'll take example from your assignment sheet itself. Look at question number 17. Look at question number 17.
Yes, sir.
This is the ring. This is the pulley. This is the mass. A. Arey, galat. It has an angle. You are able to see this part of the board.
Yes, sir.
Yes, sir.
This is VA. Kitna diya VA? 1 meter per second. VA is 1 meter per second. I'll keep it as VA right now. I don't care. This angle is 30 degree.
Yes, sir.
You are asking me VB. क्वेश्चन में क्या दिया आपने? Resultant velocity VB दिया हुआ.
Yes, sir.
Right? Resolve that VB. Resolve that VB along this length. This angle will be 60.
60.
Yes,
This
sir.
will be VB cos 60.
Yes.
The perpendicular component will not interfere with my problem. That is what I want. The perpendicular component of VB, which will be perpendicular to the length of the string, is of no interest for me. I'm happy. Yes or no?
Yes.
Yes, sir.
Only in the moment of the end point parallel to the length of the string. Parallel to the length of the string. Perpendicular component is of no concern for me. My answer will be minus VB cos 60 plus 0 plus 0. VA, I'll resolve along this direction. 60 plus VA cos 60. VA I resolved along the length of the string.
Yes.
Yes, sir.
VA I resolved along the length of the string. Net total should be 0. VA cos 60 is half. VB cos 60 is half. Am I taking the angles correct?
Yes, sir.
Yes, sir.
Yes. Sir.
I take 60 degree correctly. This was 60,
60 is
Yes,
about.
sir.
Yes, sir. Yes, sir.
Yes, sir.
right? Now half and half will go. VA is given as how much?
1.
1 meter per second.
VB will be 1. What is the answer given?
1.
Yes, sir. 1.
1,
Yes,
yes.
sir.
Now here, listen carefully. अगर कोई बच्चा बोलेगा, I will shift the board again for you, don't worry. The same diagram, look at this. Now this is fixed, this is VB, right? Now this length is VA cos 60, this velocity. Do you agree with that?
Yes.
Yes, sir.
Print will say this is 0, this is 0, there are two ends of the string. This should be, how much is VA cos 60?
1 by
1 by 2.
But
By 2. So he will tell me this velocity is 1 by 2 because both ends along the length of the string should have the same velocity.
Yes,
Yes.
Yes, sir.
sir.
This is half. Resolve this along this direction. Half cos 60 equated to VB. This will become 1 by 4, which will be wrong.
Yes.
What is the mistake he is committing? Observe carefully, here you will be convinced. This is half bold yaar. Iska this component is half cos 60, this component is half sin 60. Do you really think the ring is moving in this direction with half sin 60?
No, sir.
No.
No, right?
No.
So you understood where you are going wrong? You must resolve VB along this direction and along this direction. Whichever is the resultant velocity in which the particle is moving, that must be resolved.
Yes.
Whichever is the resultant velocity in which direction the particle is moving, that must be resolved.
Yes.
Get this point very clear.
Yes.
Yes.
Make a note of every inch of what is written on the board. First you will note this, then you will note this, right? Then you will make a note of this and explain why this is wrong. I will turn the board to the right later on. First make a note of this, then make a note of this. I'll give you time.
Sir, I have a doubt, sir.
Yes, sir.
Sir, in the
Hello.
VB one, sir, 30. Why don't we resolve the 30-degree one?
You can. You can.
अभी तो रिजॉल्व 38 तो 68. So VB cos 60.
Okay, sir, this VB is not in the 30-degree zone.
वो क्या होता है? Zone.
30 degrees. So
अरे भाई साहब वेक्टर का अगर मैंने R दिया है और A एंगल दिया है तो this will
And
be
that will be
R
R cos theta and that will be R sin theta.
now this vector का this angle is 60. I want the component.
Okay, sir, I got it, sir. Means that one is the vector. Okay, sir, I got it.
Resultant vector आपको VB इस डायरेक्शन में मूव कर रहा है. That is the resultant velocity. उसी को
Yes,
resolve
sir, I was taking in tension, sir. That's why I was wrong. Okay, sir.
the resultant velocity, whichever direction it is, that you will have to resolve along the length of the string and perpendicular to the string. Resultant velocity must be resolved along the length of the string and perpendicular to the length of the string.
So,
Hmm.
sir, in the rectangle box which you have cancelled, sir, in that I did not understand what's wrong in taking XB, like XB on the other side also, like the logic.
Now you are equating XB cos theta to XA.
Yeah.
But there is a component here. This component also will interfere with the elongation of the string.
Yeah.
It is not perpendicular to the length of the string. In this case, I can confidently tell you XA sin theta doesn't interfere with the elongation of the string.
So that's why that's wrong. So, but coincidentally, the XB and XA will be equal, right? XA cos theta will come equal. So there will be no elastic part in the string, right? The work done by both sides will be equal.
This answer and this answer are not the same. ढंग से देख लो. XB is XA cos theta is correct. XB is XA by cos theta आएगा यहाँ.
हाँ सर, मैं वही पूछ रहा था सर. मैं ऊपर वाला ही पूछ रहा था कि दोनों साइड सेम वेलोसिटी से मूव करेंगे ना.
That obvious thing. What is a constraint? Constraint का purpose is this end and this end will move by the same velocity to keep the length of the string constant.
Yeah, sir.
Sir, can you show the left part?
1 second. Let them take it down till here. I'll show.
Sir, can you again explain the right part?
This is the resultant velocity VB. He gave you that as VB. That I will resolve along the length of the string and perpendicular to the length of the string. The perpendicular component will not interfere with my problem. Along the length of the string, I will use it for the constraints. Moving towards the center, minus VB cos 60. Moving away from the center of the segment, plus VA cos 60. Net total should be equal to 0.
Yes, sir.
Sir, in all these, the VA sin theta is ignored because it's perpendicular, right?
Perfect. Along the length of the string, elongation will be 0. Only if this displacement and this displacement are equal along the length of the string. I can make a string move this way with this end perpendicular to the length and keep the length constant.
Yes,
I
sir.
can have any velocity tangential. Length of this marker is constant, right?
Yes, sir.
This point has no velocity, but the upper end has velocity perpendicular to the marker. It can have any velocity. Change करते जाओ, omega बढ़ाते जाओ.
So, but then won't that
Along
interfere
the
with the
length of the
result?
string, but along the length of the string, they should have the same velocity.
Yes.
Perpendicular, I can have anything.
Okay, sir.
This was the 17th problem from your assignment.
Yes, sir.
So, can we use virtual work in this?
Come again?
Can we use virtual work in this?
Comfortably. Comfortably you can use.
Yes, sir. Tension is same, so you can.
Sir, we'll have to resolve
Ah,
tension, right?
Hey, tension along the string ले रहे हो, displacement along the
okay,
string
sir.
ले रहे हो.
Okay, okay.
Tension को क्यों resolve?
No, sir. अगर ऐसा अलग चाहिए.
Can I shift the camera to the left part of the board?
Yes, sir.
Yes, sir.
Now here the mistake is you are taking VA cos 60. I'm happy about it. So VA cos 60 is half. You assume this end also has half velocity along the length of the string. Equate it to this, you get the wrong answer. Why?
Yes, sir.
Because then this component should be half sine 60. And the ring is not moving in that direction. This velocity is zero. So resolving this and equating it to this is a blunder. Resultant velocity should be resolved along the length of the string. Resultant velocity should be resolved along the length of the string.
Sir, so that
Ah.
will be wrong as half sine 60. There's no movement in x direction, right?
Exactly.
So, but that's because of the rod, because the rod is coming in between, right?
Their forces are balanced. Velocity कौन balance कर रहा है?
Ah, okay, got it.
Sir,
Bottom line, remember one thing. पार्टिकल का जो रिजल्टेंट वेलोसिटी है उस वेलोसिटी को आप along the length of the string रिजॉल्व कर. पार्टिकल का जो भी रिजल्टेंट वेलोसिटी है उस रिजल्टेंट वेलोसिटी को along the length of the string रिजॉल्व कर. Life will become simple. Right now you will solve your assignment question number 15, 16 and 18. I will share the screen with you people. 15, 16 and 18. I am waiting for you people. Don't type anything in the chat box. I'll not be able to read.
Completed, sir.
So the answer.
So 18th one also.
18th as well.
Answer.
Can I discuss?
Yes, sir.
Yes, sir.
Sir,
Yes.
wait. Sir, wait for a minute.
Okay.
So wait a minute, sir.
Okay.
Sir, done.
So can you tell us the answers?
One second.
नीचे
Wait,
scroll
I'll solve it on the board.
है
I'll have to scroll that down to see the answers.
Okay, sir.
Now, listen. This was BB. This was 8 meters per second. Right? This angle is 37 degree. This is VB cos 37. This end is moving. This is the first segment. This is the second segment. First segment, one end is fixed. Other end is moving away from the center plus 8.
8 plus 0.
Yes.
This is moving towards the center of the segment. Minus VB cos 37 should be 0. 8 is equal to VB into 4 by 5.
Yes.
10, yes.
So can you do one of them using the virtual work theorem?
यही कर लेते.
हाँ sir.
Absolutely no issue. This is T. T and 8 are in opposite direction.
Minus 8.
T into 8 into cos 180 plus T into XB cos 37 should be 0. Aha.
Yes sir.
So what would you say? What is easier when it comes to angles in this? With virtual work or without virtual work?
It's easier to do the questions with angles with virtual work or without.
आपको क्या easy लग रहा है आप मुझसे
वही
पूछ रहे हो यार. अब कैसा जवाब देना है? For you, what is easier? How will I answer that?
So, because both are same only, like more or less.
Yes, sir. Almost the same length.
Whatever strikes to you in the examination hall.
Whoever
You are under
prefers
pressure.
whatever.
Comfortably sitting in an AC room, I can say anything. When you are under pressure in the examination hall, your state of mind, किसने क्या दे कौन सा आइडिया जो पहले स्ट्राइक किया फिनिश इट ऑफ. We need one question का mark. Simple.
Yes, sir.
Even if it is from your neighbor, if you can get it correctly, I am perfectly okay with it.
Okay, sir.
Yes, sir.
Reasons of lecture, yeah? Okay. Now listen to the next. This is 10 meters per second. This is 53 degree. This is how much? 37 degree. This is VB. Resolve this along the length of the string. 10 meters per second. If this is 53, this is 53. 10 cos 53. This will be VB cos 37. That's the end of the story.
Yes, sir.
It is
Yes,
moving away
sir.
from the center of the segment. 10 cos 53 minus VB cos 37. एक ही बात ध्यान में रखो. Here I took velocity. Here also I'll take velocity. Here I take displacement. Here also I'll take displacement. I
Yes,
call it
sir.
XB. Sum total should be 0. VB into 4 by 5 is equal to 10 into
3 by 5.
3 by 5.
3 by 5.
Sir, उधर आपने vertically opposite angle लिया है क्या? Because it's not clearly visible.
Yeah, vertically opposite.
Ah,
angle.
okay, okay.
This is 50. Eighteenth, I'll solve either A or B. You select one.
Sir, B.
B. Sir, A.
Sir, A.
are same.
No, first people ask for B, I'll solve for B only.
It's almost same there.
This is going down. I'm unable to see this.
Sir, V.
So with V.
Velocity B, V. This is theta. This is theta.
A movable
and
pulley and U.
This block is moving with a velocity of u. This end will move with a velocity of u because this length of the string should remain constant.
Yes, sir.
Yes.
So this is the resultant velocity. I will resolve along this direction u cos theta. U cos theta plus v minus u cos theta minus u cos theta plus v is 0.
Yes.
1 second. I just need to attend the guy at the door. I'll come back in a second. Wait. Based on the same principle, can I have the board?
Yes, sir.
Yes, sir. Yes.
No, sir. 1 minute.
I thought you people are good at copying. Jaldi karo.
Dance. Yes, sir. Done. Sir, half the people here are only good at copy. Sir, done.
Sir, this same question is there in HCV, right?
Yeah.
Which many people get wrong.
Yes. Now listen. Two thin rods, smooth rods. Two thin, Smooth rod.
Smooth rods.
There is a string attached from here, which passes from inside a ring and it is connected to this ring. How is the string going? From inside the ring. So when the ring is falling, it is making the ring straight.
Yes, sir.
Yes.
आई बात समझ में?
Yes, sir.
Yes.
At one instant of time, iska velocity was u. This velocity will be, they asked v in terms of u. Find v in terms of u. Now I know you people can do it. My interest in this problem is not to make you people solve this. There is another point of constraint that I need to explain, which was traditional constraint. When I learned these constraints in 1989, I learned those constraints, not the ones taught to you people now. I had to change over the times. Now listen, first of all, what will you people do now? Segment 1, segment 2. If this is theta, will this be theta?
Yes, sir.
Yes.
Segment 1, upper end is fixed, lower end is moving away from the center of the segment with the velocity of u. So far, so good, yes or no?
Yes,
sir. Yes, sir.
This u, if I resolve along this, is minus u cos theta. Segment 2 का apply कर रहा हूं अभी. Segment 2 में this u when I resolve is minus u cos theta. For segment 2, this v when I resolve, it will be minus v cos theta. Sum total is 0. Till here, are you clear?
Yes, sir.
Now,
So how's it minus u?
Plus v.
Come again.
Minus v.
How's it minus u?
V.
V cos theta is moving towards the center of the segment.
Minus
And
u.
sir,
How's
what
it
about the v
Yes,
as
sir.
we took u?
दोनों moving
To the
towards
left
the
hand.
center.
अरे
दोनों
v को रिजॉल्व
moving
किया ना.
अरे रिजॉल्व किया फिर दोनों they are moving towards the center ना तो negative.
So both will be negative.
Okay, sir.
U cos theta, V cos theta, both are moving towards the center, both will be negative. Now, my requirement is V. V cos theta is equal to U into 1 minus cos theta. Did I take this correct? Angles?
Yes, sir.
Yes, sir. You only gave those angles.
Theta 90 minus theta, so this
Yes,
is
sir.
theta,
Yes.
right? V is equal to U into 1 minus cos theta divided by cos theta.
Sir, but this will never come negative.
That depends on the masses. Whether this is going up or down will depend on the ratio of the masses. Right now, we didn't reach that point. Till now, we will assume whatever is given in the question is correct.
So I'm not getting how. Why did you take u and then not take v?
अरे उस रॉड के along string
वो
थोड़ी है कि
rod
वहाँ पे
के नाम
velocity
string
लेंगे.
नहीं है. String is stopping at the ring, no? Second ring.
Here it is going from inside the ring. Here it is tied to this ring. So this ring will go straight, this will go straight. Ring in the rod will slide only down vertically.
Okay.
Is it clear?
So the other ring, what is happening to
So
the
we are
other
the
ring?
velocity of the
Other ring
rings,
is tied
right?
to this. The string is tied to the other ring. As this is coming down, this is moving up. For the length of the string to remain constant.
Okay.
Now, take this down. I'll explain what we used to do in 1989. Take it down first.
Sir, over
Sir,
here,
we-
the string is coming with u speed or that ring is coming down with u?
Ring. This end of the string is moving down with the velocity u. If the ring is coming down, this end of the string, the lengthening of the string is happening at a velocity u.
Yes, sir.
Can I rub the solution?
Sir,
Yes, sir.
Yes.
2 minutes, sir.
Sir, can you explain again why we have u minus u cos theta instead of this minus u cos theta minus v cos theta?
Segment 1, upper end is fixed. Lower end is moving away from the center. So it is plus u. Segment 2, this end is going down with the velocity of u. Its component along the length of the string is u cos theta, approaching the center. V cos theta, approaching the center.
Yes, sir. Thank you, sir.
Sum total should be 0.
Yes, sir, done.
This distance is taken as the d. Will that be constant?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
This distance I'll take it as y. What will dy by dt be?
So
Sir,
0.
rate of
Zero.
change of sir
Upward
u
or
actually.
downward?
Why
dy
will
by
U,
dt will be u,
U.
Yes, sir.
Yes, sir.
Yes,
dy
sir.
by dt will be u, right? I'll take this distance as, call it as x.
Yes.
What will be the length of the string? Y plus this length,
Yes, sir.
this length,
Yes, sir.
this length,
Yes.
this is d, this distance is x minus
Minus
y.
y.
Root over of d square plus x minus y whole square.
Sir, but that is a curved thing.
नहीं वो straight ही है.
तो नहीं इधर से
Acha.
So,
Will be
so we have to
straight.
assume it to be straight, right?
Right? This small inside I showed like a curve for you people to visualize that the string is going from inside the ring. It will be a sharp edge.
Okay, sir.
Somebody is asking, this will be at that instant only. Yes, at that instant only. Obviously, theta changes, everything changes. Now, what is the length of the string? Y plus this. This is hypotenuse of the right angle triangle. D square plus x minus y whole square.
Yes, sir.
Yes, sir.
Yes, sir.
If I differentiate this with respect to time, shouldn't it be 0?
Yes, sir.
Yes, sir.
Yes, sir, because
Why
length
should
is
it
one.
be 0?
Length of
Length of the
string
string is a constant.
इसका basic concept वही तो है. Length of the string should remain constant.
Yes.
dy by dt plus 1 by 2 root d square plus x minus y whole square 2 into x minus y into dx by dt minus dy by dt. You know simplification correct?
Yes, sir.
Yes, sir.
Square root of this 1 by 2 root that into differentiation of this. Differentiation of d is 0. Differentiation of this 2 times x minus y into dx by dt minus dy by dt.
Yes, sir.
2 and 2 will get cancelled out. What is dy by dt?
U.
U.
U plus x minus y divided by the hypotenuse. Can I call it to be cos theta?
Yes.
Yes, sir.
Yes, sir.
Cos theta into what is dx by dt?
V. Minus V.
Minus
V. X is decreasing. That's very important.
Yes, sir.
Yes, sir.
Sir, minus d by dt, so minus U.
But so yes, sir.
Minus sign. Yeah, this minus as it is I keep here. Right? U into 1 minus cos theta will be equal to V cos theta. Is this the answer that you are expecting?
Yes,
Yes,
sir.
sir.
We learned constraints this way. Your procedure is much easier than this,
Yes,
right?
sir. Very much.
Yes,
easy.
sir. Very easy.
Yes, sir.
Take it down till here.
Whereas our syllabus is calculus based, right?
Yeah, this is calculus based. Undoubtedly, this is the fundamental concept. You
So
should
this is
know
the
the
traditional way, right? We
Pardon?
just this is the traditional way we are resolving it and doing
We are taking the final end points and making
it.
life
Yes.
easier.
Sir, sir, like in the previous questions which we did, the one where there was no angle involved. Sir, over there, instead of taking there also we could have done the same thing, taking the entire string as one length and then
Yes. Take the total length. This side is
and
x.
then one
L
length
minus
in
x.
y.
Differentiate.
Yes, sir.
Equate it to 0. 100% you'll get the correct answer. Once in a while, I'll keep reminding you people of this procedure. बीच में कि ऐसा भी होता था. You people also should be realizing how difficult it was for us during our times.
Yes, sir.
Yes, sir. आपके समय
When you people show some sympathy, अच्छा लगता है.
Yes, sir.
सही है.
Ultimately, life is to feel happy, right?
This method was better.
Ultimately, life is to feel happy.
Yes, sir.
Sir, 30 seconds.
Wait.
Yes, sir.
Done, sir.
Now we go to the next step, the dynamic equation. Once again, I'll take the silliest possible example to solve the dynamic equation. Balance आप लोग करेंगे. Tomorrow's class will be the most important class. I will tell you a shortcut which will destroy all the lectures that we have taken till now.
Okay, sir.
Okay, sir. So tomorrow's class, who will miss, is missing the most important part of Newton's laws.
Okay, sir.
So tomorrow will you be recording the lecture?
क्यों पूछा तूने? और इसका नाम क्या है?
फिर पहले से प्लान्स बने
Siddharth. Siddharth.
सिद्धार्थ कौन सा सेंटर का बच्चा है ये?
Sir, अंधेरी.
अंधेरी. सिद्धार्थ भट्टाचार्य, याद रखूंगा. तुझे रिकॉर्डिंग नहीं मिलेगा, उसका इंतजाम कर दूंगा. राइट? अटेंड करना ही पड़ेगा.
ठीक है.
इंटरनेट कनेक्शन है, पावर का सप्लाई चला गया,
सर आपने 2 हफ्तों से तो रिकॉर्डिंग भेजना बंद कर दिया है सर.
हाँ,
चैनल पे तो
अरे
मूवी
वो
अपलोड
YouTube चैनल पे अपलोड करते हैं.
पे है यार.
भी नहीं करूंगा. अगर सिद्धार्थ अटेंड नहीं किया तो अपलोड भी नहीं करूंगा. याद करना, याद रखना. और रिमाइंड मी अबाउट दिस.
ठीक है सर.
Yes, sir.
Yes, sir.
Now listen. This is M1, this is M2. We know how to draw the free body diagram. First thing, they will ask us for the tension in the string or acceleration. These are the two variables. ध्यान से सुनो. Tonight you have lot of homework. T and T. Do you agree with this?
Yes,
sir.
Yes.
Yes.
Dynamic equation से पहले there is something called free body diagram. Free the body and draw the forces on it. M2 यहाँ पर draw कर रहा हूँ. This is T. This is M2G. I am assuming M2 to be going up with an acceleration of 8. My assumption can be wrong. The dynamic equations will take care of it. Now here I am freeing this mass and showing the dynamic equations. This is M1G. This is going up. This will be going down. तुझे कैसा पता यार? Both of them will have the same acceleration. I don't mind. Take it as V2. Take it as V1. Now principle of virtual work constraints me. T V2 positive. T V1 negative. V1 is equal to V2. A1 is equal to A2 equal to A. Okay.
Yes,
Okay.
sir.
Yes.
sir.
Now
So
my
anyways, they would
value
have same axle.
T minus M2G is equal to M2 into A. Why did you take T minus M2G? Why didn't you take M2G minus T? Naizam, this is accelerating upward. So all forces in upward direction minus the forces in downward direction will be equal to mass into acceleration.
Yes, sir.
Now this is accelerating downwards. So M1G minus T is M1A. Add both the equations. M1 minus M2 into G upon M1 plus M2 is equal to A. Is standard result. This is called Atwood's machine. क्या नाम दे रहे हो यार? Simple pulley was first discovered by Atwood, so it is named in respect to him. Atwood's machine. This is the acceleration. अगर मैंने masses M1 is greater than M2 लिया है मैंने, that's why M1 is going down, M2 is going up.
Yes, sir.
अगर M2 greater than M1 हो गया, क्या दिक्कत है आपको? Acceleration
negative हो जाएगा.
हाँ, sir.
Simple. This acceleration you substitute here or here, you will get the value of T.
Yes, sir.
Can you do that?
Yes.
Yes, sir.
I'm waiting for you. This is standard result which you are expected to remember. Before you start solving these two, always count the number of equations and number of variables. There are two equations. There should be two variables. तीन variable अगर है, please search for a third equation before you start simplifying. Number of equations should be equal to number of variables. Only then start doing the simplification. Somebody already gave the answer. Very good. M1 plus M2. These both are standard values for an Atwood's machine.
Sir, are we going to ever be using this formula, sir? Or we just going to use by FBD?
Are we going to use these formulas? क्यों नहीं use करेंगे भाई सर? आपको क्यों लगता है मैं फेरी टेल बता रहा हूँ आपको?
सर इतना सिंपल डायग्राम थोड़ी आएगा हमें.
हाँ वही तो सर.
हाँ तो ऐसे ऐसे बहुत सारे होंगे ना, मतलब
हाँ वही ना, उसके अंदर इसमें से
यही प्रिंसिपल अप्लाई करना होगा ना.
हाँ.
Principle is the same. Number of pulleys, number of masses will increase.
Sir,
Today
here
itself.
you substituted A in the first T minus M2G is equal to M2A formula, right?
I didn't substitute. Somebody substituted and gave me the answer. I copied.
Okay,
So you do the simplification. Don't copy it from me.
Yeah.
Sir, $100.
So the
stop
tension looks
writing, sir.
wrong.
Fine. Sir, $100.
क्यों?
No, sir, I was asking if the correct step was that, like substitution ka.
Obviously A to be substituted, मगर $100 दिया करो. $100 के लिए you don't need to commit a mistake to give me $100. You can happily give me $100. ये मत सोचना गलती करने से ही पैसा देना पड़ता है. Freely दे सकते. I accept donations both by cash and check.
Sir,
Hello.
won't the tension be 2 M1 M2 G? It doesn't look dimensionally correct otherwise.
Yes, sir. I was also getting the same thing.
Yes, obviously. वरना dimensionally गलत. मैंने copying गलत किया. I'm bad at copying. और जल्दी कर.
सर वो आपने M2A के लिए T minus M2G क्यों लिया? वो just एक बार just explain करोगे थोड़ा?
फिर से बोलो.
सर वो आपने T minus M2G is equal to M2A ऐसा क्यों लिया? मतलब V को include क्यों नहीं किया?
Minus M2G. यहाँ V2 इसलिए लिखा ताकि मैं constraints apply करूं. Right? Forces in upward direction minus forces in downward direction will be mass into acceleration. Acceleration is A2. So T minus M2G is M2 into A. V2 मैंने constraints के लिए लिया हुआ.
तो सर अगर M1A के लिए ऐसा opposite क्यों है M1G minus T?
ये downwards जा रहा है तो I'm accelerating in this direction. All forces in this direction minus forces in this direction will be mass into acceleration.
Okay, sir, understood.
Suppose I'm accelerating this way, forces in this direction minus forces in the opposite direction.
Okay, sir. Thank you, sir.
And sir, ये V1 equal to V2 is equal to A2 is equal to A2, वो A1 is equal to A2 वो ये आपने differentiate करके किया ना time से.
Differentiate this with respect to time, this with respect to time, and get A1 equal to A.
Just confirm. Yeah.
Can I rub the board?
Sir, one doubt. Sir, while applying principle of virtual work, we took like tension and the velocity. But one of the forces also M1G and M2G, so we did not take
work done by tension is 0. M1 M2G से work done is not 0. Principle of virtual work says net total work done by tension on whole of the system is 0. बाकी forces से हमें कुछ लेना देना है.
Oh, okay, sir.
Sir, this will work only for a simple pulley in rest, like if the pulley is in rest, right? Or will it work when it is moving?
भी अभी करेंगे, चिंता मत करो.
सर बट आपने बोला कि रिजल्ट याद करना है, बट उसके लिए तो हमें फिर से फोर्सेस को इक्वेट करके डिराइव करना ही पड़ेगा ना, एक्सेलरेशन एंड टेंशन.
5 kg 25 kg. आप सॉल्व करेंगे, मैं सॉल्व करूंगा.
हम करेंगे
सर. करेंगे.
What do we need? Acceleration of this mass, acceleration of this mass. Up for uniformity in the class, shall we assume this to be going downwards?
Yes, sir.
हाँ सर, मतलब वो तो common sense.
A1, A2. So I need A1, A2. What do I need?
A1,
A2.
And I'm begging for it.
Sir, sir, this A1 and A2 are we have considered G in this A1 and A2, right? Acceleration due
Net
to.
acceleration is A1 after all the forces taken into consideration.
Okay, sir.
So what do we have to find?
A1 and A2.
Okay.
Wait, so many answers तो नहीं होंगे. ये problem solve कर रहा हूँ. अगर ये problem से तुम लोग solve करोगे, देखो जरा.
सर थोड़ा सा टाइम सर, थोड़ा सा टाइम
सर एक ही
Sir, 10 seconds.
हाँ थोड़ा टाइम सर प्लीज.
Go ahead. I'm checking my mails.
Sir, are you checking the answers on chat?
नहीं, I'm checking my mails. हर कोई बैंक मेल भेज रहा है. कार लोन्स, होम लोन्स, they're giving it lesser interest rates. जिसको भी ऑडी, BMW खरीदना है, यही सही टाइम.
सर पैसे तो सर डाउन पेमेंट के लिए
पैसे दे दो, खरीद
होने
लेंगे.
चाहिए.
सर मेरा तो अकाउंट भी नहीं है, मुझे भी मैसेजेस आ रहे हैं खरीद लो.
सर मुझे तो व्हाट्सएप कॉल आया था कल कि आपकी कंपनी ने 25 लाख की लॉटरी लगा दी है. मैंने जिंदगी में कभी
मुझे
देखी
10,000 रुपए पर डे लॉटरी लगी है
सर को देना था वो 10 लाख.
ओके. अट्रैक्टिव इंटरेस्ट रेट्स, कार लोन्स, हाउस
सर
लोन्स.
मुझे तो जॉब ऑफर्स आ गए सर. 10,000 रुपए पर डे सर, जॉब ऑफर्स.
तो कर रहे हो कि नहीं?
तो ले लेने का ना भाई।
ले लो।
सिक्का तो ले लो।
3 लाख मांगे।
सर चाहो तो आपको स्क्रीनशॉट भेज सकता हूँ सर, व्हाट्सएप पे आया है सर।
हाँ तो ले लेना भाई, कॉलेज के बाद भी इतना ही मिलने वाला है।
डोंट वरी, वी बिलीव यू।
सर A2 नेगेटिव जा रहा है मुझे।
आ सकता है ना तेरे को।
अब ओके,
अरे
लिसन।
A2 ऊपर है लेकिन।
अरे भाई साहब रिलैक्स. This is T, this is T, this is T, this is 2T, this is 2T, this is 2T. So far, so good. Yes or no?
Yes sir.
Yes,
sir.
Yes, sir.
Now you are taking this to be going downwards. So this is your free body diagram. 25G minus T is 25 into A1.
Yes, sir.
Great. This you are taking it to be going upwards. This is your free body diagram. 2T minus 5G is 5A. These two steps, is it very clear to all?
Yes, sir. Crystal clear.
Now
Yes,
I
sir.
want to calculate A1 and A2 के बीच relation. I'll use principle of virtual
Yes,
work.
sir.
Yes, sir.
1 with a negative sign plus 2T V2 with a positive sign. V1 is 2V2, A1 is 2A2. A1 is 2A2. I will write this equation once again. 25 into 2A2. 2T minus 5G is 5A2. You asked me to calculate A1 and A2. I should eliminate
T.
Any one of them.
Eliminate T, divide this equation by 2. 5 by 2, 5 by 2, add both the equations. 25 minus 5 by 2G is 50 plus 5 by 2 into A2.
Sir, 25G minus 5.
25.
Sir, better multiply the first equation by 2.
Okay, not an issue. अब यहाँ तक आ गया तो खत्म कर दो. This will be 50 minus 5.
45 G
45.
105.
By 2 is 105 A2 by 2. A2 is 45 G by 105.
Sir, can we take G?
Yes, sir.
Sir, 3 by 7 G.
Where?
30 by 7.
With the multiplication tables of
Yes,
5.
sir. 30 by 7 and 60 by 7.
Of fine judgment.
Sir,
Hello.
the 25 you written it look like 5, so I took it as 5.
This one?
Yes, sir.
No. This is 25. It's clear.
Sir, should we substitute the value of G as 10 or 9.8?
That depends on the multiple choice options given. Generally, if they give such type of questions, they don't substitute G, they leave it as G.
Okay, sir.
So once can you repeat how you got A1 is to A2? Just that part.
T into V1 opposite direction minus T V1. 2T into V2 same direction plus 2V2. Principle of virtual work.
Okay, sir.
V1 is 2A2. Differentiate both sides. A1 is 2A2.
Okay.
Sir, I have forwarded you the message, sir.
विश्वास कर लिया फिर भी मतलब.
Pandemic has changed the life of So many people upside down. We people are lucky that we survived the pandemic.
Yes, sir.
Sir, it is
Yes,
still
sir.
on.
Intact, sir, intact.
By now I believe antibodies develop हो गया होगा यार लोगों में.
हाँ sir.
It will be on the downtrend. But
सर
yet
हमें
it
वैक्सीन नहीं मिली
don't
लेकिन
be
अभी तक
overcome.
Next month, sir, vaccine is coming for children
September.
also, sir. Next month, sir, September.
Good, get vaccinated. We can start classes, live classes as early as
Yes,
possible.
sir.
Yes, sir.
Yes, sir.
I think so. If
I
we
can't
don't
सर
wait.
रुको
that from October or November, we would be starting our
सर
classes.
सर वेट
offline.
वेट वेट सर वेट वेट
सर अगर ऑफलाइन चालू हो जाएगा फिर भी एक ऑप्शन रहेगा क्या कि जिसको ऑनलाइन करना है वो कर सकते हैं?
They'll make transition a bit slow because overnight offline भी नहीं कर सकते because local trains should come to full swing in Mumbai.
हाँ
That's
sir, नहीं तो
Yes,
कैसे
sir.
होगा?
नहीं तो हम आ ही नहीं
There
पाएंगे.
for
Figure out
traveling
the
at
सर हम लोग आ ही नहीं पाए.
offline, other online. They'll try so many mechanisms. Pace management also is getting mentally prepared for all options. ऐसा करना है तो क्या करना है, ऐसा करना है तो क्या करना है. They are also working out whatever strikes.
sir offline हो जाएगा तो मजा आ जाएगा.
Sir,
But
many
in
people will not like the offline class now.
sir, but in
Sir,
offline, sir, the teachers will again change, sir. It will be
Sir,
a
what will
blender.
be the batch strength in offline?
50-55 generally
50
होते
बच्चे
हैं
ज्यादा.
हर बैच में. 50-55 to
Sir,
60.
that is nice.
Sir, will there be reshuffling in offline?
हाँ वो तो
ऑनलाइन
होगा
में
ना
भी
सर.
होगा.
जनरली ऑफलाइन में करते हैं but पहले
नहीं
ऑफलाइन
होना चाहिए.
पहले ऑफलाइन तो होना.
सर मुझे तो चाहिए ना कि मतलब मैं सेंटर पे जाकर ऑनलाइन अटेंड करूं.
सर ये अलग है सर.
यही फायदा है उसका.
सर
Okay,
उसमें मजा
listen.
आता है.
Listen,
सामने फिर
I
भी
know it is already 5:30 but I'll take another 10-15 minutes.
Sir, no
No
problem.
problem, sir.
ले लो sir.
This is 10 kg. This is 15 kg. इसका acceleration A1 है, इसका acceleration A2 है. You are asked to find out A1 and A2.
Yes.
You will try, right?
Yes, sir.
Yes, sir.
अगर आप लोग एक कर पा रहे हो तो कॉन्फिडेंटली मैं होमवर्क दे सकता हूँ जरा.
यस सर दो.
हाँ सर ये समझना है सर.
You took T here, T here.
2T.
Tension near B.
2T.
2T.
What will be the
4T.
tension?
4T.
Dynamic equation for this. 15G minus 4T is 15A1.
Yes, sir.
Yes, sir.
All of you confident?
Yes, sir.
Yes, sir.
Yes, sir.
Here T is equal to 10A2.
Yes,
Yes,
sir.
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 Dynamic equations done. I have two equations and three variables. A1, A2, T. I need one more equation.
Yes,
So
sir.
string content.
Sir, we do the virtual work.
T
Yes, sir.
into V2, both are in the same direction. 4T into V1 minus 4T into V1 should be 0. V2 is 4V1, A2 is 4A1,
Yes, sir.
A2 is 4A1, right? So 15G minus 4 into T, I'll substitute from here. 40A1 is equal to 15A1. 15G is 15 plus
160.
160.
A1. A1 is 15G by 175.
Yes, sir. Sir, we can't see that part of the board.
So you mean to say you can't add 15 and 160 and bring it to the denominator? Why should you copy it from here? Do it on your own. Once I know A1, will I know A2?
Yes, sir.
Yes, sir. Multiply by 4.
Now have a look at these diagrams and tell me if you can attempt it tonight from the 18th,
Yes, sir.
19th problem.
No, sir, I don't.
Yes, sir. Done.
Yes, sir.
Sir,
Easy.
no,
Sir.
sir. Sir, lot of homework. No, sir.
होगा कि नहीं?
होगा सर.
होगा सर, होगा.
पड़ेगा सर. कोई
होगा
पता नहीं
सर.
होगा कि नहीं.
सर शायद
भाई
होगा
साहब,
सर.
19th प्रॉब्लम से
शायद.
31st तक बोल रहा हूँ
और संडे को टेस्ट भी है.
हो जाएगा
सर टेस्ट भी है.
सर हो जाए.
The problem. All the students who feel that they cannot do it, raise your hands. I'll get them chopped off.
Can you keep deadline till Monday?
नहीं, कल अगर आप
That
कल
is-
की क्लास में सॉल्व करके नहीं आओगे तो इसका शॉर्टकट में पढ़ा नहीं पाऊंगा. I will have to cancel the lecture.
अच्छा सर.
ठीक है सर.
तो करना पड़ेगा सर.
ये 12 प्रॉब्लम आपको आज रात को करना ही है.
ठीक है सर.
ओके सर.
ओके
AP का भी बहुत होमवर्क है.
ट्राई करेंगे सर.
सर मैथ्स का भी बहुत सारा होमवर्क है.
सर चैलेंज एक्सेप्टेड सर.
कमीनापन का भी हद होता है. 12 प्रॉब्लम्स दिया है, मैंने 120 प्रॉब्लम्स नहीं दिया है.
हाँ सर.
राइट.
आज सर समझ
12
गए, ठीक
प्रॉब्लम्स
सर.
नहीं होंगे.
हो जाएगा
सर आधा
हो
दिन में
जाएगा
तो
सर.
हो जाएगा
ठीक है
सर, हो
सर.
जाएगा सर. सॉरी.
Perfect. Get it done. Tomorrow's class, I need all the answers.
Yes, sir.
Yes, sir.
Yes, sir.
ओके सर. रेडी सर.
Two people
but
in
how will you check?
tomorrow's class.
Sir.
Thank you.
Hello.
Thank you, sir. Sir, I'm Siddharth. Sir, I was just asking for confirmation. I did not mean to bunk the class, sir. I always attend all the lectures.
ये किसके बारे में बोल रहा है?
Sir, Siddharth, sir, you had asked me to attend tomorrow's lecture, na? So I had just asked for confirmation.
ऐसा चीज मुझे याद मत दिलाना, याद नहीं रहता है मुझे. अब तू नाम बोल के खुद बता रहे हो तो आप याद रखो.
Okay.
हाँ सर जरूर जरूर.
सर कल फिर भूल जाओगे.
मजा आएगा.
Sir, मैं आऊंगा. Sir, I have not like I was just asking.
Right. And finish this homework only, then I can teach you the shortcut. Be crystal clear about it.
Yes, sir. Yes, sir.
Yes, sir.
Bye, sir. Thank you.
Bye, sir.